Welcome to INST 237 Final Control Elements Lab number 8. In this lab, we're going to be wiring another drive. Powerflex drive is the model of this one, product put out by Allen Bradley, so we are no longer using this Automation Direct GS1 drive. We're going to set this up very similar to the same way we set up the last drive. It's just going to be with a different model, a little bit more industrial, a little bit more capabilities than what the other one had. So as you can see here, the first thing we want to do is, again, we want to use a ladder diagram to wire in. L1 and L2 to bring supply power into the drive. T1, T2, T3 take power out to the motor. Now I know you can't see the wiring down here. This is where incoming power comes in. L1 and L2, they go up to these terminals here and then to the motor. We'll do a zoom in shot of that to be able to see what that looks like. Power coming in here, and T1, T2, T3 going out to the motor from there. Okay, we also have a ground hooked up, white ground again, hooked up to the drive and hooked up from the drive to the motor. So this part is all done. Okay, the motor has been checked out. Wiring's been checked out. We just need to turn the power on to the trainer. And notice our drive display panel does turn on. One thing I'm going to do is I'm going to put this cover back on the power wires, the 120 and 240 wires going into and out of the motor. That way you don't accidentally touch anything. The live connections there. Okay, so now that that cover is back on, we are ready to set up the drive. Make sure everything's working. Turn the power on. Okay, the motor turns. Turn this so you can see. You can always see the shaft turning or not, but you never hear the motor come on. You can speed it up, slow it down with the potentiometer, and then stop the motor. Okay. If you notice, this whole time the red light came on and stayed on. We'll come back to that. It's going to be different than the other one. That's came on and stayed on the entire time, not when the motor was running. That's what we want to set it up to do. We want to set it up to be on, like the last lab, when the motor was running, and then off when the motor is stopped. Okay, but the motor did run and everything like that. So what we can do with this, one of the advantages to this, is the fact that we can take our Ethernet wire and actually connect over Ethernet and download all of our drive parameters that way. But the first thing that we have to do that is to set the IP address of this drive. Okay, and so if we get into the menu, make sure we're not in any programming menus already. We just hit the escape button. Okay, and then hit enter, and then arrow up until we see the C for communication. Okay, C for communication. What we need to do is we need to do a couple of things. One, we want it to be a static IP address. We do not want it to change, and that is parameter number 128. Okay, so we enter that. That should be a 1 to make it static. I've already set this one up. So everything in here should be ready to go. And then we go into 129, 192, that's going to be the first 3 digits of our IP address. And then we go up to parameter 130, and then 168 would be the next 3 digits. So the answer to this question will be 168, and then we'll continue on. .0 .221 is going to be the IP address of this particular drive. Okay, in the same way with PLC classes, we give every device an IP address. Then we can communicate with all of them because they have different addresses. Now, everything else can be done via the laptop, so there's no more scrolling through these menus, which is good. Much easier way to be able to do that. So in order to do that, take our Ethernet cord from the laptop that we're using and just simply plug it in there. All right, so we opened up Connected Components Workbench, which is CCW. That's what that stands for. This is software that we can use to configure our drive. We are going to call this INST 237 Lab 8, followed by your initials. Then we click Create. And then we're going to add a device to this. Our device is going to be the drive itself. And that screen pops up, and device is going to be the 520 series drives, Powerflex 525. We want to select it, and we will add that to the project. Okay, and we can't connect to it yet. There we go. It should be connected to it. So we can click on this, and we want to upload from this device because the IP address is static and things like that. So we want to make sure one of the first things we do is upload any parameters that are already on the device. Otherwise, we might change things that we don't know exactly what we're changing. Okay, and we want to continue. And that way, any configuration of the drive is going to be loaded into our software here. So that we don't make any changes that we don't know that we're making. Okay, that is it. And then we go into parameters. I can make that small. Get rid of that. Now we can look at some of these parameters. Here, the parameters coming in are all defaulted. These are all just display parameters up here. And then we get down in here, and this is where we have configurable parameters. Starting down here. Okay, and so nameplate full load amps should be 1.7. Again, that comes from our nameplate on our motor, just like the last lab. So that's already set to 1.7. Poles, this is a 2-pole motor, which also makes it 36 RPMs. Okay, and so then we go. So that was the RPM of the motor for the nameplate. Then we want to change the accel and decel time, just like we did before. 60 seconds, that's something that we can see easily. The internal value, since this is in milliseconds, is 6,000 or hundredths of a second. So the internal value that it actually writes to the device is 6,000. Okay, that's the internal value. And then, if we noticed the relay in the last lab, R1 and R10 in the last lab, only came on, the light only came on whenever the motor was running. Okay, so this light here is what I'm talking about. Only came on when the motor was running. Right now, it's on all the time. We want to set that to only come on when the motor is running. This light is hooked up to the first relay, R1 and R2, for these here. Okay, and so we want to change this to motor running. Okay, and then we don't want them both to be the same thing, so we'll change this one to ready/fault, which the light was on all the time because it was always ready. It was the drive was okay, it could start, there was no faults or anything in it. If somebody pushed the start button, the drive would start. Okay, so we're just going to change the relay output to that. Okay. Once we get all of ours changed, we can now download, and we will download it to the drive. Okay, and finish. And notice nothing else changed except that light did go out. So if we were to start the motor now, it's going to take a minute to speed up. You can see it's starting to turn here. So here it starts to speed up. The light came on. Once it now started running, and then after it gets up to its full speed at 60 seconds, you notice the display, the frequency is going up over the course of 60 seconds. And if I were to wait for it to get to full speed, then we'll stop it. We'll see it decelerate over the course of 60 seconds, and then the light go out. All the same parameters as the last lab, just with a different drive and done a different way. Okay, and we're up to full speed, and it's not really changing speed at all, and so now we will stop it, It'll take 60 seconds, and then it will be stopped running. Okay, we're about done now. Getting close, and then we should see this light go off once we are finally stopped running. Okay, and that is it for this lab. You should be able to answer all of these questions and go ahead and turn your lab in on Blackboard.